Okay, guys, second video, 1.4, last video, I should say. Number 32 is what I want to start with, and it says to perform the operation and write your answer in standard form. So this is a little different. They're giving me these things with negatives under the square roots, okay? What I want to do is I want to use my imaginary numbers to try to simplify this and get this into a nice standard form. So the first thing I'm going to do is I'm just going to break these up. So the square root of -8, okay, I want to simplify that. I can write that as the square root of 8 times the square root of -1. And I can keep in mind the square root of -1 is going to be an I, right? I can do likewise here. 3 root 18 root -1. Once again, square root of -1 is an I, okay? So I have 5 root 8I plus 3 root 18I. Okay, that's looking pretty good. But you have to remember, we can simplify these radicals more, okay? If you remember, we want to try to break those into perfect squares and non-perfect squares. Hopefully this rings a bell. If it doesn't, ask. You can ask on the discussion post, on the discussion board. You can also ask me, okay? So what do we have here? I have 5. Now root 8, I'm going to put perfect squares under the first square root and leftovers here. I know 8 is the same as 4 times 2, okay? And then I have my I. So I've expanded this term right here. Why did I choose that? Well, if you go to the next step, what is the square root of 4? Well, that's 2, of course. So notice how this simplifies, okay? That's the reason I chose 4, is because I knew the square root of it. Let's see if I can do the next part. How about 18? Is there a perfect square that goes into 18? Something you know the square root of. How about 9? And 9 times what is 18? That's 2. Okay, and then I got my I out front. And I know the square root of 9 is 3. 3 times 3 is 9. So I'm here. Okay. And it actually, I can combine these because they're both I's and they have like radical. The same. If there's a square root of 3, you could not combine these, but we can. Okay. So if I have 10 root 2 I's, so this is the way I would think about it. I have 10 of these things plus 9 of these same things. Well, I guess I'm going to end up with 19 of those things, those square root of 2 times I's. So this is the answer in standard form, or if you want to be more explicit, the real part is 0 actually, and the imaginary part is 19 square roots of 2. And keep in mind, 19 square roots of 2 is just some number, some value. Square root of 2 is like 1.4, so it's some value, but we're just keeping it nice and exact, okay? All right, so let's move to one more of these. I want to look at number 38. So like I said, in this section, we're just getting used to the different operations on these, okay? So here's what I got. -12 plus root -28 over 32. I want to accomplish the same thing. So what makes sense to me is to start here. Bust out that square root -1 so I can make it into an I. And I'm here right now. Okay. Now, I want to see if I can simplify the square root of 28. Okay. And I think I can. I think I could do a root 4 and a root 7. Once again, why did I pick root 4? Well, here's the reason. -12 plus 2 root 7I over 32, right? Square root of 4 is 2. Finally, I want it in standard form, A plus BI. So I want the real stuff here plus the imaginary stuff here. You can always split the numerator, right? And then, of course, I need to simplify those, right? So I guess this would be a -6 over 16 or a -3 over 8. That's my real part, plus I can simplify 2 over 32. That'd be root 7 over 16I. The imaginary part is root 7 over 16. All right, and that does it for 1.4.